Celonis process mining is a revolutionary solution to create actionable insights on how to improve your business processes using already existing data from your IT systems. In the following, we will look at how Celonis can add value to your business. In a digital world, finding a way to leverage data to make smarter decisions is key. Celonis gives you 100% transparency on your processes and helps you to find inefficiencies and bottlenecks. Because the less time and effort that's wasted getting the tasks done, the healthier your company's bottom line will eventually look. And that goes for all processes, and your production is no different. Use cases include process optimization, process harmonization, process redesign, operational support, identifying compliance issues, and a basis for transformation projects such as the migration to a new system. In the following live demo, we will be looking at the production planning process, where we will be analyzing production activities from the order that triggered them until the respective goods have been delivered to storage. Celonis automatically generates the process graph for all production orders and allows the immediate analysis of the process. For this demo, we will be looking at a data set for the year 2016 for a medium to large size enterprise with 93,000 production orders and a corresponding order value of 280 million. Now let's jump into the process. In the header, the overall number of bicycle production orders as well as the corresponding order value is displayed. The process graph shows the most common process paths, the way that the smart Celonis algorithms reconstructed it from the data of your company's IT system. We are now following individual production orders and can currently observe that 19,812 production orders are following this most frequent path, which is initiated by a production order, after which the production order is released, the frame is mounted, the gear is mounted, a saddle is mounted, the production order is confirmed, technically completed, and finally delivered to the corresponding storage location. But there's a lot more to the process than we actually see at first. We are currently only covering 21% of all the production orders. And if we take a closer look at the variants, we see that there's 3,138 different ways we are producing the bicycles right now. Using the process graph, we can now dynamically increase the number of variants we're looking at. By doing so, we are able to shed more light onto our production process. We see that in the next variant, a large part of production orders are actually completed too late, which is undesirable for a variety of reasons. Longer time to market, not meeting customer demands, working capital issue with regard to the later generation of actual revenue, and of course the impact on subsequent processes such as the transportation or the order-to-cash process. Often the reasons for this are quite simply due to lack of production control. Companies try to prevent fluctuations in production by production leveling, which often fails due to machine downtimes and manual interventions into daily operations. In the next step, we should analyze which plants and products are involved and whether there's a way to identify root causes within the process flow in order to improve production leveling and on-time production. Let's take a look at the next variant. It becomes visible that in many cases the production order was released long before it was actually needed. And this of course has a negative impact on our working capital as well, for two reasons. First of all, we will be repurchasing new raw materials earlier than we should, and at the same time the finished product will be waiting longer in storage before being shipped to customers. Reasons can be, on the one hand, a bad demand forecasting, but can also be as simple as production managers wanting to float the number of total orders in order to reduce the KPI of too late orders. In the next analysis, we should try to find reasons for early releases so that we know where in our organization production management can be improved. Let's take a look at the next variant. We see that for a certain amount of cases, the process passes a quality inspection, which typically is part of the desired process. But if you increase the variant once more, we see that almost the same amount of orders have to be scrapped. And this is clearly not part of the desired process. What are reasons for scrap? Of course, the product could no longer be needed, but more probably, the product is incorrect or the product is of bad quality. By taking a look at processes leading to scrap, it becomes visible which products are affected, at what point in the process the material is scrapped, and how much time and effort is lost by this variant, which is why we should eliminate it. If we continue to increase the coverage of activities and connections, we are able to gain 100% transparency and overview of the tremendous inefficiency of your as-is processes. And this is where time, money, and margin can be improved. With just one glance into the process, we were able to identify inefficiencies, bottlenecks, and potential compliance issues in the production process. But now we want to go a step further and identify root causes, find out what is driving these critical patterns. On the left, we see the process graph, as before, displaying all the different variants. But now we see additional information. For example, how are production orders distributed over time? We can select the orders by their company code, but also Celonis allows you to drill down into other relevant attributes to the process, whether it's the different plants or materials that we're talking about. So let's go back into the process variant with the too late completion of orders. Let's select the activity production order completed too late. We were able to identify that there are certain peaks in January, March, as well as June of 2016. In addition, we see that there's one company code that is mainly affected by these too late completions. The drill down table on the bottom right shows the too late completions by materials. We can now switch over to the plants and see that these orders are occurring most often in the two plants, Toronto and Dortmund. Next, let's look at the process variant regarding the scrapping of materials again. By selecting this variant, we not only get information on which months the scrap rate was especially high, we also immediately see that the scrapping mainly occurred in a different company code. We can select this company code and continue from here. We see that in 4,000 cases, this process variant occurred in our plant in Montreal. By selecting the materials, we can now narrow down our root causes to two specific bicycles that we are producing in Montreal. Using this information, we can now target our improvement measures towards very specific parts of the company in order to analyze why this process pattern is occurring so often and how much time and effort has gone to waste because of it. Now let's do a deep dive analysis with regard to the adherence to schedules. The way most production processes are set up, orders are planned in a way that they are produced in time to meet the customer demand. Typically, every production order has a scheduled start and finish time. And while the good planned and well-executed production planning process enhances efficiency, delivery performance, and reduces costs, in many companies' day-to-day business, these schedules are not met. In the bar chart on the top right, we see again the distribution of production orders over time, but now in addition, we see the percentage of orders that were started too early or finished too late with regard to their schedules. Below, we see again what products were affected the most, and also the throughput time from the creation of the production order until the delivery to storage. Let's select the activity with the too late completion once more. It becomes clear that the throughput time is significantly longer throughout all different types of products. The long throughput times indicate that the delay is not caused by a late begin of the process, but that the time is lost somewhere in between. Let's dig deeper into the process. We see, for example, that in 5,608 cases, we had a material shortage with regard to the production order. This means that parts of the materials that we need for the production order were not in place. By looking at the throughput times, we can see that the impact of this on our overall throughput time was on average 3 additional days. Going one step further, we see that the quality inspection is increasing our throughput time as well by 1 day. But even worse, in quite some cases, the quality inspection leads back to the mounting of the gears and affecting the throughput time again by 3 additional days. We can now use this information to find out exactly which products are affected. Let's click on the activity of the material shortage. We see on the right-hand side that the 2 products, Thunderbolt Racing Pro and Challenger Mountaineer, are the main root causes for delays due to material shortage, which we should have a closer look at. We gained a lot of insight on why we're not meeting our production schedules with only a few clicks, and can start from here and monitor our improvement on a monthly or daily basis. Now let's jump into an automation analysis. Another important aspect of making the production process more efficient is reducing manual interventions into the process, as generally speaking, less steps equal fewer touches and equals lower costs. Over the years, does the production flow still make sense, or does it crisscross the floor in an unnecessary way? We can take a fresh look at the steps involved in the process flow and analyze the automation rate for each activity and find out root causes for why it may be low. For example, let's select the automation rate of the final confirmation of the production order. The table in the bottom right will show us how well our different plants are automating the process. We see for the plant in Chicago that has a high amount of production orders, a significantly lower automation rate than, for example, in Stuttgart. If we select this plant, we see that the automation rate has significantly dropped since the beginning of the year, and that we should start from here and target our efforts towards this specific area in order to increase the automation rate again. Taking a look at the overall process for our plant in Chicago, we will immediately notice that the production orders are completed too early and also too late, meaning that due to a low level of automation, our scheduling is suffering as well. Let's move on to an intercompany benchmark analysis. Using internal benchmarks, we are able to compare the processes of 2 areas within the company. This type of analysis can be especially relevant in order to harmonize and standardize our processes across the entire organization, as well as improve towards a defined benchmark. Key process performance indicators are calculated automatically by Celonis and help us to evaluate different areas within the company. In the header, we see main KPIs such as the number of production orders, the corresponding order value of these orders, but also additional relevant indicators we have talked about, such as the automation rate, the on-time production rate, and the throughput times. These process performance indicators are also calculated for each of our plants we want to benchmark with each other. For example, we see the plant on the left has a high automation rate and on-time rate and a low throughput time, whereas the plant on the right in Chicago has a low automation and on-time production rate and a higher throughput time. We can choose any plants we want to benchmark with each other. We can now expand the process variance in order to compare the processes in different plants with each other and see how they differ and find out what may be causing these differences. We see that by using the benchmark analysis, plants can learn from each other, exchange best practices, and improve immediately. For example, by identifying manual interventions in some plants that allows us to direct improvement measures so that they have the most impact. With the new Celonis Pi conformance checking capabilities, we can compare the as-is situation with the actual desired target process and perform automatic root cause analysis on our violations of the target model. We can import the target model with just one click or create it ourselves within Celonis. If we launch the analysis, Celonis will compare each and every individual case with the target model to identify whether it is conforming or not. We see an overall conformance KPI of only 28%, which results in 26,000 cases that are conforming with our model and 67,000 cases which are violating it. Also, we see that there are 59 different ways that we are violating our model. The conformance history shows the development of our conformance over time, allowing us to monitor whether we are improving towards a defined target model or not. But not only that, Celonis also calculates the impact on key process performance indicators. For example, the production throughput time, which is 15.4 days in the non-conforming cases versus 9.8 days in our conforming cases, showing clearly that by violating our model, our production throughput times are suffering significantly. But this is not all. Celonis provides us with a to-do list of all relevant violations identified in the model, sorted by their importance. We see here that main reasons are the too late completion of production orders in 29% of all cases, but also the too early completion or release of production orders also occur very frequently and affect our throughput time as well. Let's take a look at the too late completion of production orders, which is clearly an undesired activity. Besides additional information on this violation, like its frequency and also its development over time, Celonis Pi makes automatic recommendations of root causes with regard to their correlation strength to this violation. We see that one of the main root causes for this deviation is the plant in Toronto. Using this information, we can now jump into more details with regard to those cases. This means we get an overview of all items from the plant in Toronto that were received too late, as well as an abundance of information on each and every one of these order items. We could select one of these orders and now jump back into the process to look at its exact process flow. There are, of course, many other use cases we could analyze in this process. The Celonis Content Store offers a variety of use cases out of the box in order to get more insights into improvement potential. For example, there is a setup time analysis in which we can analyze setup time performance, meaning how much of the time is spent on preparation of machines, the gathering of tools, materials, and so on. Which processes include excessive amounts of setup time while your machinery is being prepared to produce output? Which plants and products are these processes regarding to? Reducing setup time will boost your company's capacity, increase your manufacturing flexibility, and help increase your overall output. Or also the analysis on release times, with which you can analyze the times between the creation of the production order as well as the beginning of operations. You can drill down into different plants and work centers and materials and find out where to reduce the throughput time in order to eliminate any kinds of delays. Having fast and structured production cycles will reduce complexity within your production and logistics departments. Or also, you can analyze the extensive details with regard to the scheduled start and finish times of your process. What are root causes on too early or too late start times? Or root causes on too early and too late finish times? This analysis will leave you with recommendations on how to restructure the production scheduling so that you can optimize for working capital as well as delayed production. Every answer to questions about your company's processes is hidden in your data, and Celonis is a tool to identify, improve, and monitor them. Let us change the way you see your processes.